today's session is totally about DevOps. When any of you will be going to the browser, to the internet and searching what is DevOps, so this is the definition that you will be getting. DevOps is a set of practices that combine software development and IT operations. And this is the quite beautiful definitions written on the internet. You will be, it is quite hi-fi. You will be able to read it. But if you were very new to DevOps and this is the first time you are attending session and you wanted to start your career with DevOps, then you will not be able to understand it properly. So here I will be explaining that DevOps is nothing but one of the SDLC. SDLC is what? The software development life cycle, how the softwares are being developed, how they are maintained, and how they are made available for the end user, for the customers, right? In our daily routine, we are using so many of software. Everyone is using internet, everyone is using mobile phone, whether it's Android, iOS, or any operating system is being used. So we are interacting with the software, with the application, anything you can call. So how they are being developed, the methodology used for developing them. And DevOps is one of the technique for the developing software and managing them, handling the IT operations as well. Okay, so now what is SDLC actually? This is the process produces software with the highest quality, lowest cost in the short test. Obviously no one gonna waste too much time and gonna waste money. So this is one of the key feature, that we want the highest quality and we want to spend as minimum amount as possible. Okay, so SDLC provide a well structured flow of phase that help an organization to quickly produce high quality software which is well tested and ready for the production use. So today we will be starting with the various SDLC models available in the market. So we will be starting with the traditional way. When in the early 90s or the late 80s, the traditional way that were being used, and then because of the changing requirement, the changing competition in the market, the changes are being hosted in the methods, in the terminology, and the models are changing, keep on changing. Like here we will be starting first waterfall model, then some changes or the some one step ahead is taken to this RAD model, then spiral model, V model, incremental model, then agile technology, iterate. So these are the different models that are used for SDLC for developing the software. Okay, and let us start with the waterfall model. So let us assume we are going to produce a software. So what we'll be doing, firstly we will be gathering the requirement, that what is the exact requirement, for which purpose we are producing the software, right? What features it needs, how it has to, what other feature needed to be added, what features need not to be there, which kind of software we are producing, whether it's a mobile application, it's a web application. So we will be collecting the requirement at the very first stage, and after collecting all the requirement we will be designing that how the software has to be. We will be creating a blueprint, simply a method, technique, step-by-step procedure, that the how the software is going to be designed. And after that, the third stage will be development. Now, development is nothing but we will be start coding. To make a software, we need to write down a code. You will be choosing that which coding language you want to use, whether it's Java, C++, Python, or any of the language you are familiar. So you will be choosing, and then you will start coding to create the software. Once you complete your coding, then the next step comes into testing, whether the software that the code, the piece of code you have written is working in a way like it is supposed to work. We will be testing, making tests, that whatever code, whatever we have developed actually, that the minimum value product that we can give to our customer, we have developed it. Now we will be performing testing, so that we will be checking that how it is working, whether it is working in the expected way or not, right? Once testing is successful, we are sure like the software is working in a way how it is supposed to work. Then we will be doing deployment. Deployment is what? That giving that particular software to the end users, because of the obvious reason that why we are making the software to use it. We want to do something with, whether we are making for client, for our own use, it's any of the case, we will be deployed. So the person, so the people will be able to access it, will be able to use it, whether from the customer environment, whether from our environment. So this is deployment. And once we have deployed the software successfully, we will be maintaining it, because once you have deployed, the game is not ending here, right? You need to maintain it, you need to make sure that it is working fine for all the user, for all the customers who are interacting, who are using it. So okay, so this is one of the waterfall model, that how it is designed. But you guys now must be thinking, right? Like we are collecting requirement, we are designing, we are developing, performing test, and then deploying, and then so everything is going smooth and fine, right? We are not facing any issue. So what is the need of going to the further models, to the further technologies? So let us take the example, like we are working as a DevOps engineer or a developer, we are working as a team, okay? So now we got one client, he came to us and told, like hey, I want a software like WhatsApp, right? WhatsApp is earning so many, whether it's WhatsApp or Instagram or any of the software, these are for chattings, for scrolling, okay? So whether any of the software, they are saying like, I want this type of software, right? Because this is earning a lot of money and I wanted to make money, so please make a software for me like that, I will be using it, okay? So we will be collecting the requirement, what exactly they want, and we will start our process, we'll design, deployment, testing. Now it will take a much time, like first gathering the requirement, then we will be onboarding some team to write down the codes, to design the software, to do the development, then testing. So a whole team will be needed, and it depends upon the size of the software, whether we need 100 people, 1,000 people, how many peoples we need, okay? So it would take time, like we are spending 1 month for requirement, 1 month for designing, like that. But so that the actual software will be available for the customer, for the end user, suppose within a 1 year, within a 6 month, okay? It depends upon what we are producing. So now within 6 months, within 1 year, uh, what the will the WhatsApp will be same? No, it would not be same, because firstly the WhatsApp was like a chatting app, then it added some more feature, a call for calling, audio call, video call. Later on it added some more features, like putting the status, putting your stories, right? And now I think the latest one, they have added some new feature, like people can use it for the transferring the money as well. I think this is named as WhatsApp Pay or something like that. So it, the features are being added on the software. And if our customer is reaching out to us and we have committed him, like we will be giving you the software within 8 months or 10 months, now the customer is coming back to us like, hey, WhatsApp has added this feature also, now I want this feature as well to be added in my software. Okay, so again we will be starting from the requirement, we'll be doing designing, because the traditional way was to produce the monolithic architecture. Now the monolithic application is what? The application as a whole. There are two architectures for developing the software, one is monolithic and second one is microservices, and DevOps is one being used for the microservices architecture, but the waterfall was monolithic. So we would not be saying like, hey, we have already done the design, we have already developed, we are on testing phase, so we can't host your requirement, we can't host the change in requirement, right? It would not be accepted. The customer would be saying this is of no use, now this would be a step back than what is already present in the market. Okay, so for that purpose we are not going for the watermark, because the issue was it was not able to host the changing requirements. Secondly, the results were seen in the later stages, like first requirement done, design done, development. If there is some issue or bugs, that will be seen on testing, or whether in at the time of maintenance. So the issue were detected at the later stages. Whatever efforts we have done till that particular stage are all wasted. Okay, so to overcome this issue, we went to new method, that is agile technology. This is one is also currently being used. So agile is what we will be start working with the microservices architecture. Now we will be working on different features separately. The chat feature is separate, we are having a separate feature, and the separate application, it will be a bunch of application inside application. Are you getting my point? Okay, so the next feature is working separate. So each and every feature will be having their own life cycle. We will be planning for chat only, then we will be designing, developing, testing. We will be performing all the stages, but on different features. In short, we will be working on the microservice architecture. Okay, so the agile technology comes into picture. This is the extension to the traditional technology, that is waterfall or any of the other model you can see. Okay, so next, there are so many agile technologies present, different Scrum. So Scrum will be working on the basis of sprint. In that you will be correct, and sprints are very small. Like the results were seen in the later cycle, later stages, that will be seen earlier. Sprints are small in size, like most commonly we are having 2 week sprint, 3 week sprint. So every change after 2 or 3 weeks, you will be able to see the whole cycle will be done. This whole cycle will be working on the basis of sprint, and you will be able to detect your errors or the issue, and you will be able to check whether the software is working fine or not in a small time. So the much time would not be wasted. Okay. And the second thing was, like, it will be working on micros. Firstly, like if we are adding all the features to one software, the code has to be done for 5 microservices. So every microservices means, like, firstly we will provide some working software, whether it is having only chat feature. Later on we will be adding some other features, like we will be adding some calling features, status feature, money feature. Any feature will be a add-on to the existing one. Okay, so agile technology comes into picture. Kanban is for used, Scrum is used for most of the development project where we are developing something. Kanban is used for the support project, and in the similar way, these other technologies that XP, DSTM, Crystal, these are being used depending upon the nature of the project, on which project you are working, right? Now the basic, now we come to DevOps. Now DevOps is what? DevOps is like creating the development team and the operation team. Dev refers to development, and ops for operations. So creating the all together development, testing, and operation. Testing is also including, like, in the earlier cycle, developers were responsible for developing the software. They will be writing down the code, they will be planning, creating a blueprint, and then they will be developing a code. And then they, whatever they have developed, whatever piece of code they have written, they will be giving it to the testing team, and then testing team will be performing the test. First, the unit testing. Unit testing means whatever piece of code they have written will be checking whether it is working fine or not. Then the integration testing. Now integration testing is what? Like, the new piece of code is how it is being integrated, how it is working with the already existing piece of code. Okay. And after that, the software after testing will be given to the operation team. Now the software, your application is deployed to the customer environment or is available for the end user. Now the operation team will be taking care, like, how the software is performing, is there any issue customer are facing. All that, these things will be taken care by, they will be monitoring, and then they will be making changes. So these things will be taken care by the operations team. So in DevOps, all three teams comes into picture. And, like, the second thing, like, once software is developed, it is given to test team done their work, it is given to operation team. The second problem which is resolved, the time when the software is being tested, the developers will be free and the operation team will be free, right? But in DevOps, if developer have done one feature or one thing to the software, testing is performing test to them, the developer will start working on the another feature. Okay. And sometimes it happen like the development DevOps team is work all together, it will be cross skilled. Developer will be doing tester work as well, operation work as well. Most of the time DevOps engineers are cross skilled. They will be able to, like, let us take the example, we have done the development part and we are having only two tester on team and they are on leave. So the work would not be stopped. Developer will also be cross skilled to do the tester work as well. This is the what exact meaning of DevOps, right? So now you guys would be able to understand that the difference between agile and the DevOps. For the agile, the cycle, the sprint, the whole cycle was ending till the build phase only, like the gathering the requirement, designing and then developing. After that it will be deployed in the traditional manner only. But in DevOps the cycle is of whole. It means starting from plan, code, build, test, release, deployment, and after monitoring whatever we are finding bugs, we need to improve something, we need to work on some alternate feature, so we will be planning in the next cycle and doing the same. So the whole team will be working together in the agile. Only the requirement changing requirement was hosted. If the requirements are changing, then we will be adding new features, but this was limited to till the build only. Okay, so here you guys will be getting more ideas. So first thing is to plan, and then code, and then build. So these three steps are nothing but the agile methodology. Okay, the agile methodology is limited till the build only. If we are considering plan, code, build, this is agile method. Then if we are including test as well, then it will be continuous that will be continuous integration. Test is limited to unit testing only, then it will be continuous integration. After that, if we are including integration testing, like the already existing code and integrating them with each other and testing how it is working, so it will be leading to the continuous testing. And doing release is means this is continuous delivery. If we include release as well in the cycle, then it will be having continuous delivery. And now the deployment, this is ahead of continuous delivery. Once we have tested, now we are doing release and we are planning some manual deployment. Like our software is already there in the production environment, customer are being used, but we have added some new feature, so we have done the release. So how we will be deploying? In most of the cases we will be planning the deployment. We will be adding this new feature to the production environment in some non-peak hours. Non-peak hours nothing but when the traffic on the server, on the software, on the application is low. So if there is some issue, so the minimum number of user will be affected. Okay, so this is nothing but the manual deployment. And if when once the cycle is complete and after the release, it will be automatically going to the production environment, then this is nothing but the continuous delivery. Okay, continuous, there are three major steps. First one is continuous integration, then continuous delivery, and then continuous deployment. So continuous deployment is a step ahead than the continuous delivery. And after that, operate and monitor comes into picture. Operate and monitor is nothing but how the software is working. We will be making eye on that, and we will be checking if new feature has to be added, or there is some other absolute feature has to be removed. So this is nothing but the continuous monitoring. Okay, and all it together, all, if we are covering continuous integration, continuous testing, continuous deployment, continuous delivery, then continuous deployment, continuous monitoring, each and everything is being used, then this is nothing but DevOps. DevOps is the method where all these things will be done together. Okay, let me check your chat window. If anyone is having any doubt, and I will be seeing it. Okay. Okay. As of now, chat window is clear. So let us proceed further. I will be taking a pause here for 2 minutes. If any of you is having any doubt, then please you can put on chat window, or if you are okay, then you can give the thumbs up. So I will be proceeding further to the next. I can see so many thumbs. Actually, people have raised their hands. Could you please unraise them if you are not having any doubt? And if you are having any doubt or any question till now, please put it in the chat window. Are you guys with me? Anyone of you, please confirm if you guys are able to hear me properly. Okay. Okay, so Muhammad is saying, I want to know the difference between release and the deploy. Okay. So Muhammad, as I already explained, release is what Release means that we are ready with the software, like whatever we have built, we have tested, and it is working fine, and it can now be sent to the production environment. Okay, so this is nothing but the release, that we are absolutely ready with the change, with the whatever thing has to be done from our end, we are ready with it. It is continues now. And in case of customer, if we're working for particular customer, then we have given them the whatever we have built, whatever we have produced. And continuous deployment means that make whatever changes you have done, whatever feature you have, making it available to the end user, means deploy to the production server, and now end user will be able to access it, will be able to make the use of it. Okay, so this is the basic difference. Okay. Okay, and Arun is saying, I would like to know how much coding. Arun, if you wanted to be a developer, then obviously you must have a good hands on with the coding. But if you want to be a DevOps engineer, then most of the time, DevOps engineer are not the one who will be writing down the code. Okay, they will be taking the code from the developer, and rest of the things will be taken care by the we will be discussing the roles and responsibility of DevOps engineer. Okay, and Pratik is saying, yes, ma'am, you're audible. Thank you. Can we use iterative model? Okay, so Karthik is asking, can we use iterative? Yes, of course. Iterative means nothing but the add-ons. So iterative DevOps is also one of the iterative model only. Okay, in DevOps, sometimes we follow partial DevOps, like we will be making sprint, but the cycle will be of till the operation team only. Okay.
Ma'am, sorry for the interruption. We'll have the question answer session separately at the end of the webinar.
Okay. Okay. So thank you, guys. We'll be proceeding further as we have a limited time. So if I will be proceeding further. Okay. And I will be answering all your question one by one by the end of the session. We are having a separate time for Q&A. Okay. Okay, so now we will be moving to the features that the DevOps architecture features. So, what are the features that DevOps has? First one is collaboration. Collaboration between the two departments stand at the very base of DevOps operation. While it does require cross-functional teams and discipline, as well as may result in the changing of predefined roles. Suppose I am working as a in DevOps, developer. Okay, and we are working in a DevOps way. I mean, we are working in a DevOps technology. So I may be working as a tester later on. Like I am working for one whole year as a developer, and I know how it is working. So obviously, I will not be writing the code again and again, coding, because changes are always loved. Okay, then I might be changing my role from developer to tester, and then from tester to DevOps. And so the collaboration is done at a very high level in DevOps team. The team will be cross functional. Okay. And the second thing is automation. Now, while the developing department generally has a high level of automation, we don't observe the same with the operation side. By integrate the same level of automation in both department, we achieve a level of consistency and efficiency across the board that would be not otherwise possible. Right now, what is automation means? As we see in the agile, it was limited to the build, that continuous integration. The build thing was done automated. After coding build, the cycle was going, but most of the time it was not equally implemented at the testing side and the operation side. Okay, but in DevOps, the automation is from end to end. It would be starting from the very first thing, that is from the thing you are seeing in this dark blue color is the continuous integration, and this one you are seeing in green is in the continuous delivery. And most of the time it refers to the operation team, and this refers to the development team. Okay, so most of the time it was limited till the development side only, till the continuous integration. But in DevOps, both are automation is equally important as well for the integration side, for the teams deployment and monitoring side. Okay, this is one of the DevOps feature. And the third one is integration. I have already told you that continuous integration, continuous delivery, it will be we will be doing add-ons. And third one is configuration management. In this one we will be discussing later slides that the whatever configuration we have done for the version 1 will be managed, will be stored, and in any time we wanted to go back to the older version, then it would be possible. We would not be losing anything. We will be just adding more feature, testing them. If they are working in the supposed manner, then it will be deployed, it will be releases from us and will be deployed to the actual working software and will be available for end user. And if not, then we will be going rolling back to the previous version and will be working accordingly. Okay. Okay, now the thing that DevOps tools, how many DevOps tools are present in the market, how the DevOps is achieved, because this is nothing, DevOps is nothing but the set of practices. Okay, you have to follow in your development life cycle, so that the set of practices you will be following, so the DevOps will be achieved. It is, DevOps is not like you are going to a market and buying it. You have to implement, you have to create a cross skill team, you have to implement the automation, you have to done the integration, you have to done the code management properly. So all these set of practices will be making DevOps together. Like you have first, very first key feature is you have to done the continuous integration, then you have to do continuous testing, whether it's unit testing or integration testing, it should be continuous. After that you have to do continuous CD. You must have heard CI/CD. Okay, CI is continuous integration. CD is sometimes refers to continuous delivery and sometimes to continuous deployment. As I have already told you that deployment is a step ahead to the delivery. And in most of the production cases, we are stopping at the delivery only. We would not be going to the continuous delivery. Like most of the time, we will be going for the manual deployments only. It will be scheduled weekly once or weekly twice, like that. And but in the rare cases, the continuous delivery deployment is done. Okay, so CED sometimes refer to continuous deployment, sometimes refers to continuous delivery. Okay. And, okay, continuous integration is one of the practice, continuous testing, continuous delivery. And third one is microservices. As I already told you, DevOps is the one that is being used for the microservices architecture only. If you are developing a monolithic, that a monolithic trend is, I think nowadays is out of trend. It is absolute now. So most of the time you will be working with the microservices architecture only. The microservices architecture is designed approach to build a single application as a set of small services. Each service run in its own process and communicates with the other services through a well-defined interface using a lightweight mechanism. Typically, it would be on HTTP-based application programming, some using some API microservices. Okay, so these are built around business capability. Each service is scoped into a single purpose. If you have split like you want 5 feature into your software, right? So you must have to split them and you have to choose which one is the firstly provided to the customer. Like if we are producing application that must offer a chatting feature, a money feature, money transfer feature, we wanted to put a story, we wanted to do a video call, video chat. Okay, so you have to first identify that which is the most required, which on which you wanted to work first, which is the most burning requirement. Okay, let us suppose we wanted to start with the chatting feature, or we want only audio video feature, and we have to divide it accordingly, and then we will be working, right? First we will be providing the some in MVP is nothing but the minimum valuable product. That obviously when we are working for client, they are putting money as they will be providing some money, so at least they must be given some working software, right? In DevOps we will be judging the progress on the basis of MVP, that is the valuable product, what thing you are giving to customer, or whether you are providing only updates like we are planning, we are coding, we are building. It's not like that. You DevOps rely on the basis of that what product is actually available. Okay, so and so in DevOps, it's up to you that how many tools, how many technologies, how much automation you wanted to add on. You can add on the nature of your project. What is the and result you wanted to achieve, you can add as many tools, technologies depending upon you. And the only thing that we want, this whatever software should be we are providing must be reliable. It should be working. It's not like that we are spending time, and at the end what we are getting nothing, but we are having so many bugs and problems when our software is in production. Okay, so it's like here we have there are listed some few tools like for coding. Git and Subversion is the most currently being used in the market. And then Zira is one of the ticketing tool, Eclipse is one of the EDI, Maven is one of the build tool, Maven and Gradle. These are for building. Now building is what, when we have written the code, we want to package them, right? We want to package it into some jar file, war file, okay, that can be shipped from one environment to another, from one place to another. So this is nothing but the building. And coding, that writing down the code for your application. Then for performing testing, here Selenium and JUnit is listed. So we will be doing test whether the code is working fine or not. Selenium is JUnit is used for only Java. If we are developing the application in Java, then JUnit can be, but Selenium, I think Selenium is also for Java, and I think it can be integrated with some other languages also. I have not worked with Selenium, so I'm not sure. But JUnit is especially for Java, and it can't be integrated with the other language. If you are using some other language for coding, then the tools may vary. In the market, there are a number of tools present for different language with different features, and you have to choose accordingly that what is the nature of your project, what you want to achieve by using this particular tool. Okay, and then Bamboo and Jenkins is one of the orchestration tool. Orchestration is nothing, once you have done your coding, you have stored in some source code management tool, and from there it will be taken to build, from there it will be taken to test. So the step by step is flow is controlled by the orchestration, by doing the automation. Like if one thing is done successfully, it will be moving to next stage, then next stage, then next, then from plan to code to build to test to release. So one by one it will be moving automatically. So these things are done by the Jenkins or Bamboo. And might be some other tools as well, but Jenkins is one of the most used. And as of now we are getting some cloud based orchestration tool as well. Like if you are using AWS or Azure or GCP, they are having their own orchestration tools that you can use. Okay, but these are the third party tools which can be integrated with the any of the cloud or any of the tools you are using. These are the third party tools. And then this Chef, Puppet, Ansible, these are also doing the same work, but with different features on different mechanism they will be working. They are used for the configuration management. Like if you are handling so many servers, okay, so how you will handle the configuration, what is exactly happening on each of them, each of the servers, how will you manage the configuration of each of the machine, each of the server, whether they are on prem or on cloud. Okay, so these are being used for the configuration management. And in the similar way, for operate, for monitor, we are having different Prometheus, Grafana, ELK, or so many tools are there to monitor. Okay, and in our session we will be discussing each one of them. For coding we will be just discussing Git. Okay, and for build we'll be discussing Maven, then we'll be discussing Jenkins. And there are one more thing, there are two type of application deployment. Now one is the containerized and second one is the non-containerized. Okay, I think containerized is the new to market, and this is booming in the market currently because of its features and the users and the benefit it is providing to us. But we can work accordingly any of them. If we are okay with the build, whatever we have built, and we wanted to deploy it directly, the jar file, war file you have created of your code, and you wanted to deploy it directly on your server, so this is the way where you are not doing any containerized of your application. You are deploying it directly and making it available to your end users. So this is the way, that is non containerized application. And The second way is using containers, which is being vastly used in the market, and it's a new technology. I think few years back it comes into picture. So this one is the containerized. We'll be discussing what is the benefits of using containers, why they are being used, for which application will be used. But as of now, I hope you guys got some clear idea that what exactly is tools being used. Okay, then afterwards we will be starting from code. I mean, we'll be discussing each and every stage, and we'll be seeing that how they are being used, what tools are available, what feature they offer. Okay, so now let's proceed to SCM or VCM. SCM is source code management, or VCS is version control system. Now what is this and what is being used? If you will be searching SCM, VCM in your computer, you would be easily get to know what are they, what tools are available. But here I will be making you guys understand by taking the example. Let us suppose I am working on some software. Okay, we are producing some software. Okay, we give firstly the customer the V1 version. Okay, because we are getting like on our regular application, we are getting some updates, and after each and every update, we some future features are being removed, new features are being added. But these are nothing but the version. The current version, then next version may have some add-on features, next version may have some add-on feature, and depending upon the monitoring or the observation that IT team is used, this feature is never being used by the end users, then they might be removing that feature. Okay, and we will be getting a newer version. Okay, so the thing who take care of this thing is the version control system. Like I am writing down the code, and I have developed it with the one feature, and I am done. Now I am adding some more feature to it. Okay, I am proceeding to version V2. Later on I am adding some more feature, I am proceeding to version V3, and next I am removing some absolute feature. Now I am with the version V4. Now at the version V4 I am realizing that no, this version is not working fine. I wanted to go back to the previous version. Okay, so in this case we need to keep a track on every version, like what features were there in this version, what was the code changes I done to go to the second version, third version. And I would not be taking care of these things by myself. I would not be creating a folder in my system and writing this is V1 version code, this is V2 version. So we need some automated tool that will be taking care, that will be controlling the versions, and that will be managing the source code, whatever source code we have written for the application. So these tools are nothing but the source code management, or sometimes refer as a version control systems. Okay, and in the market we are having two type of source code management. One is the central, and second one is the distributed. If we talk about the central, then SVN, you guys may have heard about the subversion. Okay, so subversion is one of the tools that work on the basis of central mechanism, and Git is one of the tools that work on the distributed mechanism. Now we will be discussing what is central. In the central, this is a repository. Server repository is nothing but the remote place where you will be storing your code, whatever files you have written, whatever script you have written for the application. So you all will be storing on the server repository. And if you are making directly changes, you are doing some change to any file system. A means nothing but, suppose there is one developer A that is working on his system, so he will be making some changes to this repository directory, and there is some other person, developer B, who will be working on this particular machine and making changes directly. So this is nothing but the centralized version control. We will be having only one repository, and each and every developer will be interacting with this one directly. Okay, so this is the centralized version control system, and SVN is the example of this. SVN is work on the basis of centralized mechanism. And now we will be moving to distributed one. In distributed one, what happened? In the same way, there will be some similar repository would be there,
One
like
second, ma'am. Sorry for the interruption. You can take a small break for 10 minutes so that our academic counselor Manjunath will
yeah,
be.
I will be taking a break at exactly at 5:45. We'll be taking a short break from 5:45 to 6. That would be of 15 minute. Okay, we will be taking that break. Don't worry. And if anyone is in hurry, then they can go now. There is no restriction.
Yeah, once he done with the presentation, you can continue the session.
Yeah. Will be taking break at 5:45. Only 3 minutes are left. I will
Okay,
be able to
okay.
complete this. Okay. Thank you so much. Okay, so now the central repository is same, but here how the developer will be working, they will be creating a copy of it in their local system, and they will be making changes to it. Once they are sure, they will be doing changes, and once they are sure they wanted to add them, only after that they will be pushing it to the central repository, and from the central repository the code will be taken to the production or the testing or any further stage where code will be taken. Okay, so this is the distributed means you will be having two working copy of your source code. One is in your local system and second one is on your server, on remote server. But in this case we are having only one working copy that was present on the remote location only, and if the server crashes or anything happen, then we would not be having an alternate solution, or we will not be having a copy, would not be having backup. But in the distributed one, we will be having two copies. One is on our local machine and second one is on remote server. That is remote repository is nothing but the place where your things can be stored, whether it's file or your videos or anything where you are storing. Okay, so we were discussing about the version control or the source control, whatever you can call it. Okay, so the source code, whatever code you have written in any of the language, number of files, it's a, so it has to be controlled, it has to be saved, it has to be taken care by automatically, and for that we are having different number of tools. After that, uh, we'll be proceeding with the git, because I have given you the example of the svn and the git, and git is one of the most used version control. And here we will be discussing the flow. Before discussing the flow, I will be showing you guys that what git exactly. Let me open my personal account so you guys will get more clarity. This is let's just move to any of the repository. This is GitHub. This is the remote repository we are using. If we are using Git, so GitHub is the remote server or remote repository offered by Git. If you will be using Git, then this would be the remote repository you will be using. Okay, so this is called GitHub, and the Git on which you will be working, you need to install a software named as Git, that you will be installing on your system, and you will be doing search. I think I might be having in my system. Now I don't have as of now. Okay, so you will be using git bash it is called. And then from here you will be copying the files into your local repository, making the changes. Once you are sure, like you wanted to commit them, you wanted to add into remote from where the code is taken for the software exactly, then you will be pushing it to the remote repository, and that's done. Okay, so I'll be, this is one of the file. Okay, and you whatever changes, it has almost 12 line, whatever it is written, if I am removing any of them, I need to edit it and I will be remove this. So this version will also be saved. If I am adding new one, this version will also be saved. So you have to go to just history, and you will be able to see that what you have done. Like I have removed ansible, added cloud, so you will be checking, you will be providing some message, and that will be shown here why at the time of doing commit, like what you have done. And if you wanted to go to the previous version, then you can simply move to this one. It will be showing you that these lines were added because this is the first creation. And in this post this, uh, this line 10th and 11 were added. So how, this is how it will be taking care of your actually this is the only sample 5. I have listed some tools, Kubernetes, Ansible, cloud, and written thank you. But in the real working environment, you will be writing a piece of code that will be actually building an application. Okay, and it will be showing you what you have actually added on this particular file, and then what you have removed. So if you wanted to go back to any of them, any of the previous version, then it would be a game of a single click, right? So that's how the version control system help you, how it manages the source code for you. Okay, here now we'll be discussing the flow. Okay, Okay, so this is working directory is nothing but whatever you have cloned into your system, whatever files is present in your system, you first have to do git add. After doing git add command, it will be this all actions are performed on your local system, and these things are performed on remote. Remote is nothing but the GitHub, and local is whatever you have cloned from remote to your local system. So this is your local machines. You have to after making the changes, you have to do git add. Then after adding, these will be taken care by the git. Now if you wanted to save the changes, you have to do git commit. Commit is nothing but saving the changes. Okay, now the changes are saved into your local machine, and you wanted to add to the remote repository, okay, from your local system to GitHub. Then you have to do git push. Once you do push, the all the changes you make into your local will be now sent to the remote repository. And actually you will not be the only one who will be working, okay. Suppose there are two developer, three developer who are working on the same remote repository, they will be doing the changes and pushing them. Now git pull or git fetch, sometime we are fetching, sometime we are pulling. So it will be, you will be pulling, like whatever changes are present. The difference between your local machine and remote, if someone has make some changes, you will do a pull, and you will get all the changes into your local now. Okay, and if you are getting the changes for the very first time from remote to local, then this is called clone. Okay, the terminology is different. Git clone is cloning the getting the changes for the very first time. And once you are having into your local, now you wanted to make sure if something has been changed in the remote repository, you wanted to get that changes into your local files, it will be git pull. And git pull is equal to git fetch, git merge. Before pulling, you can review. If you are doing git fetch only, then you will be able to fetch the changes. To see the changes are there, you will be able to merge it into your local file. So git pull is equal to git merge, git fetch plus git merge. Okay, so the terminologies may be different for the whole, but this is how it works. And git checkout is nothing like you have created different branches. Branches means one branch that is actually the code whose code is being used in production, and second branch is like where you are adding new feature that has to be done testing and check whether we want to implement or not. So we will be creating different branches. Branching strategy depends upon you. If you want to create a different branch for each and every developer, you can create the branch. Okay, so you will be able to move from one branch to another, and another to third, fourth, how many branches you have. So for that you will be using git checkout. So this is the whole workflow how the git works. I hope it would be clear to you guys. Okay, now we'll be moving further, and we will be moving to Jenkins. Now Jenkins is nothing but the orchestration tool. It will be doing the process automate. It will be helping you to achieve the automation one by one. Like suppose this is the first stage. Commit is nothing but saving the changes to the version control. Once you have saved your changes to your version control, you make some changes, you will be creating a new war file or new jar file that is build. For commit, we will be using git subversion. Any of some cloud are also providing the version control. We can store our code on Azure or AWS as well, or you can use any third party tool like Git or subversion. Okay, after that, once there are changes in the code, the next stage, you will be moving to build. You will be building a binary jar file, var file, and whatever you have prepared, whatever you have built, will be doing testing. This testing, you might be using some different tools, Selenium, JUnit, NUnit, any of them. And once testing are done, they will be moving to the stage. Like this is the development environment where we are developing the software. After doing development, there will be some stage. Staging is nothing but performing like the pre-production environment before deploying to the production environment, where this application will be actually in working state. There will be some staging environment as well. And once staging is done, then you will be deploying to the production environment. Now you have no need to take your code from one place to another place to third place. It does not matter how many stages, how many steps are there in your pipeline. Okay, the the Jenkins will be taking care that what to do with the code once changes are done, how to fetch it, where to take it. And after the build is successful, successful, testing is successful, it will automatically taking it to the staging environment, and after getting the approval it will be deployed directly. So Jenkins is doing nothing but the orchestration. It will be helping you to achieve the pipeline, the flow, how the workflow goes. You have not to take a changes are done, now take that changes and build is manually. So it will be reducing the manual effort, you have not to do anything manually. So it will be doing archis. I hope it will be clear that what Jenkins is and how it is helping us to do the things faster to achieve the automation. Okay, and similar to the Jenkins, there are also tools available like Bamboo is one of the famous orchestration tool, and Hudson is the older name of Jenkins. Hudson and Jenkins are same. Earlier it was called Hudson, and nowadays it is called Jenkins. Okay, so let us take the example like we are working on some project we are making, like the earlier we were taking the example that one feature is already in production and we are working on the second feature. Developer are writing code for the second feature, they are sure it is working, so they will be pushing it to the GitHub. Okay, the GitHub, you will be pushing the code to the GitHub, and from GitHub a new build has to be taken. For building, here we have used Maven, for example, Maven or Gradle or Ain't. There are so many build tool available, but as here we are using Maven. So once the build is available, whether it is in the form of jar file or war file, we will be testing. For testing, here in the example we have used Selenium, and once the code is tested successfully, we have deployed on it Tomcat server. Tomcat is nothing but one of the server, Apache Tomcat, where your application will be deployed, from where it would be accessible, right? And once they are deployed, we will be monitoring how the application is working, how, what is the efficiency, proficiency, everything, what are the result, what are the user experience. We will be collecting the feedback as well. Okay, so these all things will be step by step, from one stage to another to third. And if there is some issue with the testing, it is not testing successfully, the pipeline will be failing here, and we will be going back to the developer to make the changes. So all these things will be taken care by Jenkins. It will automate the whole process from planning, coding to the release, deployment, and monitoring. Okay, like these are the benefits of using CA. You can, we can skip that, as you can Google them out and learn what are the benefits. Okay, so here I will be show I have shown the actual dashboard of Jenkins, how you will be like we were using GitHub, right, for the source code management, then we were using Maven for building, we were using Selenium for testing, we were using Tomcat server. So we are using number of tools. So how Jenkins would be able from one to integrate from one tool to another? So there are plugins are nothing but the thing that make it possible, the integration between Jenkins and any other tool available in the market. In Jenkins we can integrate up to, I think, more than 1000 tool you can use, like available in the market, more than 1000 tools. It offer you the opportunity to accommodate all of them. Like here you will be creating new pipelines, mean new item means you will be creating pipeline. There are different way to create a pipeline, we will be discussing that. But in Jenkins, if you want to integrate with GitHub or Maven or Selenium or any of the tool present in the market, Ansible, Kubernetes, Docker, Tomcat, AWS, any of the thing you wanted to integrate, what you have to do, you have to simply go to the plugins. Each and every plugin is available in Jenkins. You have to search for the particular tool name whichever you wanted to integrate. Once you search it, you have to download the plugin it downloaded, then you have to go to the configure system. You have to provide like you have downloaded Maven. Okay, then you will be providing the path to that particular Maven, and you will be, if for some tools like for GitHub we need the credential, actually no one will be allowed to access your GitHub, your code, because it is we need credential. Okay, then you have to simply go to the manage credential portal. You will be providing the credential and making Jenkins available to go to that particular tool and get whatever things we have defined it has to do. After going that, it will be performing accordingly. Like it will be taking the war file from one place, and then it will be going to Tomcat server and deploying it. It would be needing the credential, it would be needing the permissions you must have, your Jenkins must have, okay, so that it will be able to deploy. So the process will be automated, and these are the features given by Jenkins how to integrate. And I think there is no tool that cannot be integrated with Jenkins. Each and every tool present in the market now would be can be integrated with Jenkins, right? Okay, so how to create the pipeline? Now, pipeline is nothing but the step-by-step flow. What like firstly build, then test, then deploy. So the flow, one step-by-step flow is in the cycle is called pipeline. So there are three different ways to create the pipeline in the Jenkins. First one is manual, scripted, and declarative. Both the scripted and declarative are pipeline as a code. You will be writing a code script, and for that you will be using GUVI is one of the language which is being used for writing the scripted for writing the pipeline. And these are two different syntax, only the syntax difference is there. One is scripted and second one is declarative. And the manual one is just creating the pipeline by the dashboard. You will be going to new item, and then you whatever plugin you have installed, you will be getting the option that from where to get the code. You will be getting option if you have installed two plugin Git and Sven, you will be getting two option. You have to choose, then you have to provide credential, and then you have to define what it has to do. So all the things when you are doing by the manually one by one. Okay, so this is nothing but the manual pipeline creation. And if you are writing the pipeline, the script, the piece of code to write down the pipeline, then it would be pipeline as a code, right? As the name indicates, pipeline as a code means creating a pipeline through a code. And there are two different ways, one is scripted and second one is declarative. We'll be discussing them, that what's the difference. Okay, the only difference is of syntax. Like in the scripted one, you need to write down node, this is the script, and the whole pipeline will be in the curly braces open, curly braces closed. And each and every stage is nothing but the thing. Like for coding, for checkout, like build stage is there, we will be defining what has to be done here. Then the test stage, we will be defining what has to be done there, here, and then deployment. Okay, and in the similar way in declarative, the syntax will be different. It will be starting with pipeline, and the whole script will be in the curly braces, open curly braces, then close curly braces. Okay, and we will be defining agent. Now agent would come into picture when you are using slave master. Like like if we need Jenkins to be used with Docker, Maven, SonarQube, JUnit, number of tools we can use. Okay, and but we can't install each and every type of environment on one server. It will be overloading, the server will be slow. So for that case, we will be using different servers, and here we will be defining that this pipeline has to be run on which server. Okay, so agent is being used, and the stages will be same. One stage, there will be a particular stages block inside stages. There will be each and every stage, but in here there was no special block for stages, it was defined directly. Okay, so the syntax difference is there. Okay, and now like this is the commit, means from GitHub it will be moving to second stage, and then after seeing whether this stage is passing or not, it will move to third, fourth. In the similar way, your pipeline can have up to 50, 100, or so many stages you can have. There is no up limit for defining the stages. And once each and every stage is passing successfully, then it will be deployed to the production server, and we will be achieving the software. For example, I will show you guys one of the real working script. And there is no hard and fast rule that you need to define your script in Jenkins only. You can store your script in the source code management, and you can provide the path, so Jenkins will be going and checking where the script and running the stages accordingly. Okay, so right, this is one of the script that was being used in one of my personal project. So I have written the pipeline. Like the first stage is checkout. I have written the code, as I already told you, this has to be done using GUVI. So all this is written in GUVI. So the first stage is checkout. It has to go to the GitHub. I have provided the GitHub path where my code is stored. Okay, and I have given the credential which branch is has to be used. After that, once the Jenkins is able to clone the repository, to clone the code, the second stage is to build, and we are using building using Maven. This is the command. Sh is to use to write down any of the command, okay, the whatever Linux command you want to run. So we are using Maven. And the third stage is to doing quality analysis. Now analysis means analyzing the code. Whatever code you have, we will be analyzing it. Analyzing means we will be checking if it has bugs or vulnerabilities, or code smells, or in there is any issue. So this is simply analyzing the code. And analyzing is of two type. One is static and second is dynamic. If you are doing it without executing code, then this one is the static. And if you are firstly executing then testing, so dynamic. So for that we are using SonarQube. SonarQube is also one of the tools which is used for analysis. And once we are getting the report from Sonar that these many bugs are there, these many vulnerabilities are there in code, now if we wanted to go ahead, so we will be providing some threshold condition. Like we will be defining if 5 bugs are there, then it's okay, move ahead. And if we will be defining bugs are more than 10, then no need to move ahead. Our pipeline will be failing at this stage only, it would not be passing. Then we will be making to the changes to the source code, and we will be again running the pipeline. Once we are running the pipeline and it is going successfully, then we will be storing our war file, jar file to some repository. Nexus, JFrog, these are the repositories where you can use your store your artifacts. Okay, so this stage will be, you will be using to store the artifact. Now artifact is what? When you are using Maven to build the artifact, so it will be creating a war file. And this war file has to be stored on this particular Nexus repository. That URL we have to give, that particular credentials you have to give. So it will be storing your war file to the repository, and from there you will be deploying to the production server. Okay, so this is one of the pipeline that we have written for Jenkins. It will be moving automatically one by one step. And your pipeline can have up to 50, 60, no matter how many stages you want. It depends upon you that how high quality. It is better to do much testing, much analysis before go sending your code to the production. So you can add as many stages you want, as many tools you wanted to integrate, you can use. And you can create the pipeline before deploying your artifact to the production, right? Okay, so we are done with the this Jenkins part as of now. I hope you got. And it's not up to the integration only. The in CI is this is being used for whole CI, CT, that testing or anything. The end-to-end pipeline can be created, and there can be separate pipeline also. Once you have created your binary build, you are storing them to the to some artifact, right? Then after that your CI pipeline would be ending, and after that you will be creating new pipeline that will be fetching your binary build and deploying to the production server. It depends the mechanism how you are using it, totally depends upon you. But the Jenkins will make it easier. It will be doing the automation for you. Okay, let me check if anything is there in the chat window before proceeding to next. Chat is saying 11. What is commit? Actually, Kanaya is saying what is commit. So commit is means saving the changes. When you are making changes to any file, okay, the changes, so it would not be saved automatically. The first thing you need to add them, like you in your repository you are having only 3 files, you have added new file. Okay, so the first step, this is the hierarchy, this is a mechanism how Git works. So firstly you need to add them. Once you are added, they will be tracked by Git. Until you don't add them, they will not be tracked by Git. Okay, so once you are sure you wanted to save the changes, you have done changes to any file, you have added new file, any change, whatever change you are doing, if you have done any change you wanted to save, so this is commit. Commit is means change, saving the changes. Yeah. You're welcome. Okay, I hope you're clear now. Now we will be proceeding because I don't see any further doubts till now. So the next thing we will be moving to Docker. Docker is what is one of as we have discussed one of the pipelines here. I'll be right. So this is what we were using. We were seeing building, testing, and then deploying directly to the Apache Tomcat, Apache server. Okay, so this is the example of non-containerized application. And for containerized application, we will be using Docker. It means containers, and Docker is one of the containerization tool. Okay, so Docker does what like containerization means packaging your app. Let us take the example like I'm working on a code. I'm a developer. I have written a piece of code. Now I have tested it is working fine. So I will be giving to the testing team so that the testing team can test it, right? Whether it is working fine or not. So I will be sending this file to the test. They will be testing it on their PC. Now when we are writing the code, so not the code is gonna work, we will need some libraries, some dependencies, like for writing the java must be present in our system. Few more libraries and dependencies should be there. Every library and dependencies have their own version, and different versions support different features. Okay, so in my machine I have would have taken jdk 11, or in the tester machine they would have taken some different version. So the code, whatever code is written, would not be working same in their system because of the dependencies and libraries, right? The only piece of code I have written on file would not gonna work. We must be needing dependencies and libraries, and if we want them to work in the same way that it is working on my machine, so the other person must have the same versions of dependencies and libraries. Are you getting my point? Now the tester would be using some different dependencies in the library, and they will be saying, Mandeep, whatever you have written is not working fine, so there you need to make changes to your code, it is not working, right? And I would be saying, I have tested it out, it is working fine, there is issue with yourself, go and see it. Okay, so there will be a blame game between the developer and the test person. So what Docker does, instead of packaging your code, it will package all the dependencies, the libraries, all the thing it will package together so that your application will run independent of environment. You have not to take care of your environment. All the things that is needed to run that particular application will be packaged together and shipped together, right? The container you will be seeing here, this is one of the application. It does not care about the environment, what environment you are using. Okay, so it will be working independently. So that's what the container help us, how we use container. Like if you want to run Jenkins on your machine, to install Jenkins, what you will be doing, firstly you need Java, and then you need to create some a repository for storing the artifact, and then you will be writing some commands to download Jenkins. Okay, that's how it work. But if you are using Jenkins image, Jenkins container, then you have to do nothing. You have to simply run that container, and everything will be there. Whatever the pre-request is for that particular application, you have not to take care. You It would be done, taken care by the image is nothing but the application package, and once you run that image, it would be container. So container is simply the running instance of image in case of Docker. I hope I'm making sense and it is clear. Okay. Okay, so there are the benefits that Docker offers us. What is the benefit of using containerized application over the non-containerized application? Okay, so these are few benefits. First is rapid deployment. If I am installing, the pre-request is the library first, and then I am installing that particular application and making, so obviously it would be packaging it, and we have not to take care of the environment. If I'm using Windows, Linux, Mac, whatever my machine is, I have not to take care about the environment. Obviously it will increase the deployment rapid. It will if you are running 5 application, one of them is using Java 8, second is using Java 11, so they would not be interfering with each other, they will be running independently. And developer productivity, obviously, if we are like I have already given you the example of the scenario, so it will be increasing the productivity. Once whatever I have done, I have given them the as it is. But if we are not using container, then it is not possible that I am I am copying my C drive and giving to someone else, right? But in case of Docker, it is possible whatever libraries, whatever dependencies are used, you will be packaging them together and giving them to the other person. So there will be on your machine, you will be I will be showing you guys one thing, like Docker Hub. Okay. So Docker Hub is nothing. These are the images. Like if you wanted to Docker search Jenkins. Okay. So now if you want Jenkins to run on your server, on machine, right? So you will be searching here, install Jenkins. Right, so you will be getting different things, like you wanted to install it on Ubuntu or on which OS you are currently working on, Windows, on Linux. Then they will be given some commands like these things. These are the prerequisites you need to install. Okay, then you will be able to run Jenkins, right? Like these are commands, what are the prerequisites you will be seeing here. Okay, how to install. Firstly you need to update, then Java, whatever Java you have taken, what is the version, then you will be downloading Jenkins and you will be able to run it. But in if you are using Docker, so you have not to take care of this. What you need, you need to install Docker and you have to take this image, this particular image. Now you are all set to run Jenkins. And now you want Tomcat, so in the similar way you will be taking image, you will be running it, right? Are you getting my point? So what is the use of Docker? You have not to take care whether you are which operating system you are working, how it is working, it will be running independent. And on Docker Hub, whichever is having this green tag, it means this is recommended by the official Docker Hub people, whoever is handling this Docker Hub, who the owner company, right? So this is the verified image. But if you wanted to do some changes or anything, even I can push my images to this Docker Hub. This is the public repository where everyone can contribute, right? If you see, these many people have given their Jenkins images. All of them might have some different features, they have added some add-ons or they might have changed accordingly, but this is the one which is verified by Docker and recommended by Docker. And for every each and every application you will be able to find, like let us search for Tomcat. Okay, so you will be able to see. Now after this you will be container orchestration and management. In the real world we would not be dealing with only one application, we will be dealing with the number of application. Our application will be available for the customer in number of containers. So if I want to run only one container, I will be going to Jenkins, I will install it and get it done. Okay, but what if I wanted to install 50 container, 100 container? So you need someone, like in case of Jenkins you were not doing each and everything one by one, you were doing just setup and Jenkins was taking care. In the similar way, there are some container orchestration tool that will be taking care that how the container has to be built, delivered, deployed, run. They will be taking care automatically. How you will be able to manage thousands of container all together, right? Like, so in the market there are so many popular tools are available, like Kubernetes, OpenShift, and some of the cloud based, like Amazon is offering EKS service. In the same way Azure is offering some managed service. So there are number of tools available, but Kubernetes is one of the famous tool that is being used by the in the market currently, which is covering the more area in Kubernetes, sorry, in containerization and Redshift. So there are number of orchestration tools available, but Kubernetes is one of the most famous among them. Okay, so this is the Kubernetes, this is the architecture, that how it works actually. In orchestration we are having number of tools like Docker Compose, Docker Swarm, each and have them different features. Like if you want only one node on one machine, you want to run multiple container, then Docker Compose is best. You have to write one file and 10 container, 12 container, whatever you want to run, you will use Docker Compose. But if you need multi nodes, like your container are running on different server, on one machine, two machine, you are using 10 machines, right? So this is nothing but the multi node orchestrating. So this could be done using Docker Compose or Kubernetes. Now Kubernetes is third party tool, but Docker Compose and Docker Swarm is taken care by Docker only. Okay, so Kubernetes third party, but this is being used most widely in the market. And this is the architecture. We will not be going into that depth because this is the introduction session only. So in Kubernetes it will be might be hard to set up the cluster, but the cluster strength will be much greater than the Docker Swarm. So each it would take some time to set up the cluster, but Docker Swarm could be faster than it. So every tool has their own feature, own advantage. You have to choose what you want, what you want, cluster strength or you want speed. Okay, so you have to choose the uh, tools accordingly. That's what I told in the starting. It does not matter which tool is necessary to use. It depends upon your project's nature, right? And in the similar way, Ansible, what it will do, if you are managing 100 machine, what is the status of each machine, what prerequisites each machine need, you will not be opening one laptop or going to one server, logging in and then installing some prerequisite to each of them. For that we are having some configuration management tool, Ansible, Chef, Puppet. What it will be doing, you have to write down the files and it will be taking care that all the things are done on the all the server, whether you are having 10 server, 15 server or 1000 server. So it will make your work easier. And it contribute in DevOps because we have to provide the reliable software at much faster rates. So it will be helping you in this way. And in similar way, Terraform is one of the infra as a code. Infra as code means what? If you wanted to create some resources on AWS or Azure, you will be going to console launching them. But using Terraform you can manage all of them. You will be writing the script and running the script for AWS for one count, for two count. You can replicate your infrastructure. So infra as a code, Terraform is one of the examples that for the infra as a code tools that will be helping you to create the infrastructure. Infrastructure is what? That your server, your auto scaling, whatever you want to do with your infra, it will be able to create that and manage that. Okay guys, now I think we are all good with the tools that you must at least you start with these tools to be a DevOps engineer if you wanted to move to DevOps. So these are the tools that being used or you must have go through to start with the DevOps. Okay, so I think we have covered almost. I have prepared one questionnaire as well, but it has already taken so much of time. So we will be having Q&A session first. If any of you want to ask anything, please, chat window is open. Please post your queries here. I will be answering them first. Then will be, if we are having extra time, then we will be taking care of the questionnaire that I have prepared for you guys. I will be taking a pause for 1 minute, guys. If you have any queries till now, whatever we have covered, you can post. I will be stop sharing and I'm waiting for queries for next 1 minute. Okay, so someone is saying describe Ansible little bit again. Okay, sure, I'll do that. Okay. So Ansible is one of the in configuration management. Like suppose you are having 5 servers, okay, and you have deployed your application on these 5 servers. User will be accessing from them, okay. And for your application to run, there are some configuration need to be done. Like you want to install Tomcat on all of them because you will be deploying application on Tomcat, right? So instead of going to server one by one and installing Tomcat, what you can do, you can use Ansible. And Ansible, what it will be doing, it you will be writing a playbook in which you will, what you want to do, you want to install Tomcat, okay, right? And in the host file, you will be providing on these many hosts, whether you have 5 server or 50 server or 15 server. How many servers you have to provide the IP of these host, and you have to write down in playbook that what you wanted to do. So Ansible will be doing that for you, right? If you are having only one server, two server, then it would be easier for us to going them and installing things or making the configuration by ourselves. But if we are having 40 server, 30 server, 50 servers, or no matter how many servers you have, then you have not to do the repetitive work installing Tomcat on each and every machine. Ansible would be doing, you have to provide them the list that which task has to be done and on which machine it has to be done. So Ansible will be doing that for you.